Alright, so we're doing the same thing today as we've been doing the last 2 days. Solving systems of equations, but now we have 3 equations with 3 variables. So our problem could either look like this. So it can look like this, where we have 3 variables in each equation. Or it's going to look like this, where we have one equation with 3 variables, one with 2, one with 1. If it looks like this one in row echelon form, we would just take the one that has only one variable with an answer, and we plug it in, and then find y, and then plug it in. So we just are working backwards. If we have it looking like this, where we have 3 variables and 3 equations, it's a little bit more work. It's like 2 steps longer than what we've been doing the last 2 days, but we'll get to that. First, we're going to do example 1, which is just in row echelon form. So we want to take z is equal to 2, plug it into this z in the equation above. We can't plug it into the first one because we can't solve for 2 variables at once. So we want to plug it into the one that's right above it. So we have y plus 4 times 2 is equal to 7. And we solve for y. What do we have to do first to solve for y? 4 times 2, which is 8.
Minus 1.
Y equals negative 1. Perfect. What do you think we do next? How?
Plug it into the first equation.
So we're going to plug in y and plug in z into the first equation. So we have x is equal to, or x minus 2 times y, which is negative 1, plus 3 times z, which is 2, and that's equal to 9. What do we do first to solve for x? Multiply. What's negative 2 times negative 1? Positive 2, and 3 times 2 is 6. We can add 2 plus 6, which is 8. Then subtract. So what do we get for x? 1. So we have our x, y, and z. We've got to write it as a coordinate pair. So how would we write this?
1, negative 1, and then 2.
1, negative 1, 2. So it just goes x, y, z. Alright, the next one says that we are testing a solution, so show that the ordered triple is a solution of the system. So we just want to plug in 1, 0, and 2 into our equations and see if it works. So we have 1 minus 3 1 minus 3 times 0 plus 2 is equal to 3. We have to check all 3 of them to make sure they work. So this is 1 minus 0 plus 2. So 3 is equal to 3. So this works. We can check the next one. Again, we plug in our x, y, and z. So 2 times 1 plus 0 minus 5 times 2 is equal to negative 8. So 2 minus 10 is equal to negative 8. This is true, so that works. And then again, plug in our x, y, and z. 1 minus 0 plus 3 times 2 is equal to 7. This is 1 plus 6 is equal to 7, which is true. So for this one, if we wanted to, we could solve our systems of equations and get this as our answer, and that would prove that it's a solution, but it's a lot less work just to plug it into each equation and see if it all works. In example 2, we're using back substitution again. So we're just working backwards. So what are we going to plug z is equal to 8 into? The first equation or the second one?
Second.
The second. Got to plug it into the second first. So we have y plus 2 times 8 is equal to 6. Solve for y. Y plus 16 is equal to 6. Subtract 16. What do we get for y? Negative 10. Now what do we do? Plug it into what? We found our z and we found y, so now we need to find x. We can't plug it into the second one because there is no x. So let's plug it into the first. So we have 2x minus negative 10 plus 5 times 8 is equal to 24. Just combine our like terms. So 2x plus 10 plus 40 is equal to 24. 2x plus 50 is equal to 24. Subtract 50. 2x is equal to negative 26. What do we get for x?
13.
Negative 13. So how would we write our answer?
Negative 13, negative 10, and then 8.
Negative 13, negative 10, then 8. So we got to write our x, y, then z. All right, when we have 3 equations with 3 variables, this lists out all the steps in words, but we're just going to work it out. If you ever get stuck, refer back to this, because it just explains how to do everything. But it's not as clear to see when you're reading in words what to do. It's just easier to see it in the problem. So let's work it out. So first thing we're going to do, we have 3 equations. We want to work with 2 at a time. So we're going to work with the first 2 first. And we want to cancel out one of our variables. So which variable should we cancel out in our first 2 equations? X. We already have a positive x and a negative x, so we want to cancel out x. So the x's cancel, and we just add everything else together. So what's negative 2y plus 3y? Y. And then what is 3z plus c? So plus 4z, and then 9 minus 2? 7. Now we already worked with the first 2. We just have to work with a different pair. So one of them is going to be repeated, but we just can't do the same 2 again because that would give us the same thing. But we have to cancel out x. Since we canceled out x to start, we want to cancel out x again. So which 2 do you want to work with now? The first and the third, or the second and the third? The first and the third? Our goal is to cancel out x, so what do we have to multiply times the first equation to get our x to cancel?
Negative 2.
Negative 2. So we have to multiply everything by negative 2. So this is negative 2x plus 4y minus 6z is equal to negative 18. So now we got to combine them, cancel out one of our variables. So x's cancel. What is negative 5y plus 4y? Here.
It's canceled out.
Negative 5 plus 4.
Oh, no. It's negative 1, or just negative y.
Negative y. And then what's 5z minus 6z?
Negative negative z.
Negative z. And what is 17 minus 18?
Negative 1.
Negative 1. So now we have our two equations with two variables, so this looks exactly the same as what we were doing yesterday. And we just solve from here. What do you want to cancel out here, the y's or the z's? The y's. The y's are already set up for us to cancel. We have a positive and a negative, so these cancel out. What is 4z minus z? 3z. And what's 7 minus 1? 6. Solve for z, so divide both sides by 3. Z is equal to? 2. What do you think we should do next? Awesome. We are going to work backwards and plug it in, but we can't plug it into one of our original 3 because we have 3 variables and we can't solve for 2 variables at once. So we have to plug it in to one of these 2. And we're going to solve for y. So do you want to plug it into the pink one or the blue one? Pink. So it doesn't matter as long as we're plugging it in to z. So we have y plus, oops, this is 2 here. So y plus 4 times 2 is equal to 7. Y plus 8 is equal to 7. What do we get for y? Negative 1. What do you think we should do next? Plug it into what? One of the original equations. Now we're going to plug in our z and our y to solve for x in one of the originals. So which one do you want to work with? First one. So we have x minus 2y, so 2 times negative 1, plus 3 times 2 is equal to 9. Got to multiply. So x plus 2 plus 6 is equal to 9. And combine like terms. X plus 8 is equal to 9. What do we get for x?
1.
Awesome. So we got our x, our y, and our z. How do we write our answer? 1, negative 1, 2. Our x, our y, and our z. All right, let's look at the next example. So we want to cancel out one of our variables, and we can only work with 2 equations at once. So which 2 do you want to work with here? First and second. And what do you want to cancel?
Can it be either the x or the y?
It can be either one, just as long as you stick with one. So somebody said x first, so let's cancel out the x's. What do we have to multiply times our second equation to get the x's to cancel? Negative 2. So I'm just rewriting the first equation. I want to multiply everything in the second by negative 2. So we have negative 2x plus 4y minus 2z is equal to negative 16. Our x's cancel. What's y plus 4y?
5y.
5y. What is 3z minus 2z?
Z.
And then 9 minus 16?
Negative 6.
Negative 7.
Yeah, negative 7.
All right, so that's our first equation with 2 variables. Now we got to find another one. So we have to work with a different two equations. Which two do you want to work with now?
First and third.
Sure. Let's do the first and the third. What do we have to multiply by which equation to get our x's to cancel? Because remember, we canceled out our x's to start, so we still have to cancel out our x's again. 2. Perfect. So we're multiplying everything in our first equation by 2. So that'll give us 4x plus 2y plus 6z is equal to 18. Our x's cancel now. What's 3y plus 2y? 5y. What is 2z plus 6z? 8z. And that's equal to negative 4 plus 18, 14. So now we have our two equations here with two variables. What do we want to do next? Awesome. We want to multiply the top equation by negative, so the y's cancel. So I'm just going to change the sign of everything in here. If you want to multiply it by -1 and rewrite it, go for it. I just changed the sign of everything.
It wouldn't change anything if you did it to the bottom one, right?
Right, you'd get the same answer. So it wouldn't matter if you want to multiply the top by -1 or the bottom by -1. You'll end up with the same thing. So our y's cancel. What's negative z plus 8z? 7z. And then what's 14 plus 7?
21.
Divide both sides by 7. What do we get for z?
3.
3. All right, so we got one variable. How do we find the next?
Plug it into one of those two equations that we had.
Which one do you want to plug it into, the first or the second?
The first.
Doesn't matter. Either one, as long as we're plugging it in for z. So we can plug it into the first. So we have negative 5y minus 3 is equal to 7. Add 3 on both sides. Negative 5y is equal to 10. Divide by -5. What do we get for y?
-2.
-2. So we got our y and our z. How do we get our x? Plug it in where?
In the original equation?
Plug it into the original. You want to plug it into the first, second, or third? Sure. Second looks a little bit easier. You can plug it into the second. So x minus 2 times -2 plus 3 is equal to 8. So x plus 4 plus 3 is equal to 8. X plus 7 is equal to 8. What do we get for x? 1. How do we write our answer? 1, -2, 3. All right, example 4. Which two equations do you want to work with first?
First and the second.
The first and the second. And what do you want to cancel?
The x's.
Sure, let's cancel out the x's. So what do we have to multiply times our top equation to get our x's to cancel? -2.
-2.
So we have -2x minus 2y minus 6z is equal to -14. I'm just going to rewrite the second equation right below it just so I can keep myself organized. What do I do next? Combine them. So our x's cancel. What's negative 2y minus 4y? Negative 6y. What's negative 6z plus z? Negative 5z. And negative 14 plus 7? Negative 7. What do I need to do next?
You have to cancel out the, wait.
Yep. Let's work with the first and the third. So we could either do the first and the third or the second and the third. The first is definitely easier because that x it doesn't have a coefficient in front. So we're only going to have to multiply one of our equations by something. If we did the second and the third, we would have to multiply both of our equations by something. So the first and the third is perfect. What do we have to multiply times our first equation to get our x's to cancel?
Negative 3.
Negative 3. So you have negative 3x minus 3y minus 9z is equal to negative 21. Combine our two equations. X's cancel. What's 5y minus 3y? 2y. What's negative 4z minus 9z?
Negative 13. Z.
Negative 13z. And negative 6 minus 21?
Negative 27.
Negative 27. Now we got two equations with two variables. What do you want to cancel out here, the y's or the z's? The y's. What do we have to multiply by our second equation to get it to cancel out with negative 6y?
3.
3. So multiply everything here by 3. So we have 6y minus, what's 13 times 3? 39z. And that's equal to negative 27 times 3. Negative 81. So we're combining these two together now. What happens to the y's? Cancel. What is negative 5z minus 39z? Negative 44z. And that's equal to negative 88. Solve for z. Divide by negative 44. So what's z equal to?
2.
2. So we got z. How do we find y?
Plug 2 into one of those two equations.
Which one? The green or the blue?
Top one, the green one.
Sure. Let's plug it into the top. As long as we're plugging it in for z. So we have negative 6y minus 5 times 2 is equal to negative 7. Negative 6y minus 10 is equal to negative 7. Add 10. So negative 6y is equal to 3. Divide by negative 6. What do we get for y? Positive or
Negative
negative?
1/2.
Negative 1/2. So we got our z and our y. How do we find x? Plug it into the original. Which one? Sure, let's plug it into the first. So we have x is x plus negative 1/2 plus 3 times z. 3 times 2 is equal to 7. So x plus minus 1/2 plus 6 is equal to 7. We can subtract 6 on both sides. So x minus 1/2 is equal to 1. And we can add 1/2 to both sides too. If we wanted to, we could multiply everything by 2 to get rid of that fraction to make it a little bit easier to work with. But it's just 1 plus 1/2, which I think we can all handle. So how do we add 1 plus 1/2?
You have to find the common denominator.
What's our common denominator on 1 going to be? 2. So we have 2 over 2. So what's 2 over 2 plus 1 over 2?
3 over 2.
3 over 2. Just add the numerators, keep the denominator the same. How do we write our answer? 3 over 2, negative 1/2, and 2. Perfect. All right, let's work out the last one. Which two equations do you want to work with first?
First and last one.
First and the last. So what do we have to multiply and by which equation to get what to cancel? What do you want to cancel out? Yep. We can multiply the first one by a -1, so just change the sign of everything. Combine it with the last one, so we get our x's to cancel, 5y minus 4z is equal to -2. Which two do you want to work with next? Second and third. So again, we have to get our x's to cancel. What do we need to multiply by our third equation to get them to cancel out? -2. So multiply everything by -2. So this is -2x minus 4y plus 6z is equal to 3. So we're combining these two together now. Our x's cancel. What's -y minus 4y?
-5y.
-5y. What's -2z plus 6z? 4z. And 2 plus 3? 5.
5.
So now we're working with these two equations. We want to cancel out y's first because we already have a positive 5y and a negative 5y. So they cancel. What happens to our z's?
They cancel.
They cancel. So we're just left with 0 on the left side.
Is there no solution?
Does 0 equal 3?
No.
Nope, so no solution. So if you get everything to cancel and you're just left with 0 is equal to some number, it's no solution. If you have 0 is equal to 0, then it would be what?
No solution.
Infinitely many solutions.